Hello and welcome to this week's episode of the weekly AI Yap, where I just cover the news from this week's week in AI, and then I'll just talk about it for a little bit and whatnot, right? And so for this week, the main pieces of news, right, are OpenAI. They've released GPT-4o voice mode. You have Mira Murati leaving OpenAI. Then, after we finish up with the OpenAI stuff, because it's a drama, right? It's like Game of Thrones, but for AI people, right? Then you have the new Gemini models, Gemini 1.5 Pro and Flash 002, like V2 of those models, that are 2 million context window. You have Llama 3.2 Vision and embedded, so you have the 1B, 3B, 11B, and 90B, I believe those are the sizes. And then you have molmo, right? And so I'm just going to start by talking about the OpenAI stuff, because I know if I just let myself, I will talk about OpenAI for the entire podcast, like I did last week, and I think I'm going to just get it over with, and then we can talk about Llama 3.2, because there's some really cool stuff there. And so, with OpenAI, obviously, you finally have the release of GPT-4o voice mode, right? So now you can get on a live voice call with GPT-4o, and they announced this back in April, May-ish, and so they announced it the day before Google I/O, so they can show, oh, look at the cool stuff we're doing that Google isn't. And then immediately after Google I/O, they had Ilya left OpenAI, right? And so they were kind of just trying to blot out whatever Google was announcing at I/O, right? And it's like, okay, they announced voice mode, so they dropped 4o, right? They legitimately dropped 4o, which it's GPT-4, right? It's not an intelligence upgrade, it's like an intelligence side grade, right? And so they dropped 4o, and then they haven't had voice mode for a while, right? So you couldn't actually use any of the multimodal out of 4o, right? So 4o was really felt a lot like GPT-4v for a really long time, and now you can actually use multimodal out, but only through voice mode, right? And so you have the voice right now, but it's still not the full feature set they promised back then. Back then they promised having camera, so you can take a photo or whatnot, and they didn't really deliver on that yet. That's still in the works probably. And so what they did here is it's just a voice call. You can't have it give it a picture of your get on a voice call and give it a picture of your fridge, and then tell you what to cook, and it will tell you what to do and tell you if you're good or whatnot, you're cooking or whatnot. No, it's just voice, right? And so I think that's fundamentally not that great. Cool, you have voice, but open source is really close to catching up with that, right? Because you have the Qtai Moshi model, right? Moshi is a model that's the entire thing is it's end-to-end speech-to-speech, right? And so it's cool, you have that. And it's 4o is a cool model that OpenAI doesn't let people use the cool parts of, right? We can't do image generation directly from a 4o. You still have to use DALL-E 3 if you pay for ChatGPT Premium. You can't use any of the multimodal out. And this is the first time they're allowing you to do that, and even then, this isn't the full feature that they promised, right? And so I think this is fundamentally just OpenAI trying to, back then, being hey, look, we have this thing in development. Look, very cool, to just try to steal some thunder away from Google. But Gemini 1.5 Pro was a very good model. Gemini 1.5 Flash is a pretty good model for that scale, right? And so it's okay, cool, but you didn't drop the cool stuff. You just dropped effectively a side grade. It's GPT-4v, but sure, it's a little bit smarter and better at vision tasks and whatnot, but it's not really a massive upgrade from the smell test, right? And so, yeah, this is just kind of OpenAI, announcing stuff, not really doing anything with it. Voice mode was kind of the similar situation to Sora, but then, they dropped partially. And so, yeah, and then OpenAI is also no longer a nonprofit. And they haven't been acting like a nonprofit for a while. They've been acting a lot more like a for-profit enterprise. Now it's just legally signed and dotted. Sam Altman has equity now. Mira Murati has left the company, right? And I think my running theory is that she liked the nonprofit aspects of it, but you never know, right? You just never know with this type of stuff. And so this is just OpenAI doing a bunch of stuff in the background, and it really feels like it's a drama show, but for AI people, it's just now they're one of the people in the race for making the next generation of models. So the effects of this drama show do affect everybody. And so it's okay, cool. But like OpenAI, they've been kind of doing their own thing, kind of meandering. But then now I'm going to stop talking about OpenAI because I know if I keep talking about them, I will extend this to like 25 minutes. And I'm going to stop now. And I'm going to get to the new Gemini models, right? And so the new Gemini models, they're very good, right? I may be a little bit of a Gemini apologist, right? I really like the Gemini models, right? But like a million context window was very good. It's an amazing models, like the context window size, right? Because like the best you really get with anybody else is like Claude's 200K, but Claude's 200K is like effectively probably only like 32K, right? And Llama 3.1 does have a full 130K, but like, cool. Like, it's like you have a million context windows. There's stuff Gemini can do that other models just can't. And now they've released Gemini 1.5 Pro and 1.5 Flash version 2, right? So 002 at the end, if you're using it via API or whatnot. And so what these models are, they're just 2 million context, right? So whatever you can do before, you can do again. So previously these were experimental, right? These were the Gemini 1.5 Pro experimental August 6th, right? 080624 or 2408, whatever the order is, right? It's the August 6th thing. And they were experimental. Google just wanted to see how do people actually like them and whatnot. See if they held up in production. And now they've actually released it, right? The models are faster, they have longer context, they have a whole bunch of cool stuff like that. And so now what you have is you effectively have the models with like effectively like what is this, like 20 times the context window of like the closest. And if you do count Claude's like 200K like real, like sure, 10 times the context window. Like you can do so much with this context window, right? Like you can feed in entire textbooks raw and then have it be a subject matter expert, right? You can feed it like all your data and it'll be a subject matter expert, right? And so I think this is just Google's compute advantage like showing up. Because everybody else is limited by compute, right? Because it scales exponentially, right? Like context window scales exponentially. But Google, because they have so much compute and so much CPU, instead of like attempting to train models that are like, sure, maybe like 2% more intelligent, they're extending the context window to an absolutely insane length, right? And so they talked about the 10 million context window that they have internally. Though what I think is that 10 million context window exists internally, but it's not like an effective context window. Because the new Gemini models, they're releasing with like 2 million effective context window. And so I think what they're doing is they're effectively trying to extend the effective context window of their internal Gemini 1.5. So that now what they're able to do is they're able to get to the full time. So when they reach a 2 million effective context window, release that as version 2. When they reach 3 million, release it as version 3, right? And so they're able to just like extend the effective context like over time of the internal model, and when it's ready, they release it. And then as they're training it with that, the intelligence goes up and the models become better, right? And so I think I'm a big Gemini apologist, right? I love Gemini. Gemini is a great model, massive context window, makes for some great stuff, right? And I think this new set of models is just an iteration on what came before, right? Like I don't think that Google will release Gemini 2 before I/O, right? I think Gemini 2 probably comes out April to May during Google I/O, right? I think Gemini, I think and they're probably going to go again with a Nano Pro and Ultra, I believe the sizes were. Yeah, a Nano Pro and Ultra. And they'll have the whole gamut, right? Though I think they might rebrand the Nano to Flash, because Gemini Flash is like good, right? Like I think they're probably having Flash for a small, really fast one, Pro for like the standard task, and then Ultra for if you need extra performance, right? And so, yeah, the new Gemini models, they're really good. They're really good. They're just an iteration of what came before, and it's just like the way I've always described Gemini, right, is that they're models that for tasks that other models are able to do, they're not necessarily as good. But for tasks that other models are not able to do, they are the best you can possibly have, right? Gemini is a model capable of stuff, other models simply aren't, right? And so Gemini existing is just another tool in the toolbox, right? So if you're building like a RAG system or whatnot, like Gemini as a model is just really cool for now, because now you can feed entire swaths of data, right? And then it's just another tool in the toolbox, right? You like compose these models in different ways. You have the like large data set searcher be like Gemini, and then you have like the talk to user be a model like Llama 3, Llama 3.1, or I guess now Llama 3.2, and you just have a lot of that capability. And so I think Gemini as a model is just, it's really good. Like I really like Gemini. Gemini just kind of fits with so much stuff. You feel it, yeah. I love Gemini, though I might just be a Gemini apologist, right? Then, now you have the big news. You have the really big news, right? You have Llama 3.2. you have, in Llama 3.2's family, you have the small models, so the 1B and 3B, and then you have the vision models, right? So the multimodal ones. That you have 11B and 90B. I believe those are the sizes, but I might be off by like a little bit, right? And so let's start with the embedded models, because those are much simpler. So those are just more distillations of Llama 3.1. So in essence, these probably should be closely related to the Llama 3.1 family, but they're releasing it with Llama 3.2, so it's part of the Llama 3.2 family, right? It's kind of how Llama 3.1, 4, 5B is effectively Llama 3, 4, 5B. It's just because they had extra context and a whole bunch of stuff, they set it up so that now it's Llama 3.1, and then they've generated the 8B and the 70B as distillations, right? And so here the 1 and 3B are distillations of 3.1 models. There's no vision in the 1 and 3B. This is just so that these models exist exclusively so that you can run them on embedded devices, right? So you can run them on a phone, you can run it on whatever, right? And so now, let's say you're a company and you're trying to make a local LLM, and because these models are fast, like they're really fast. And so, in essence, like these models exist just to be really small embeddable models that you can throw on any device and they do really good work, right? So they don't have vision just yet. And so these models, I think, they kind of operate in a similar area to like Quen 0.5B and 3B, and also like Phi 3B and like Gemma 2B, and like those really small models that they exist entirely on embedded devices, right? Like you're not throwing them on servers and hosting them, because at that point, it's like not very efficient, right? Because when you're running inference on these models and you have a lot of VRAM available, you might as well throw 8B, right? Llama 3.1 8B, or I guess in this case you want to throw in like the vision model. I guess it depends on your requirements, right? But like you want to throw in like a bigger model, right? And so if you want speed, like probably like the 7, 8B is probably the range you want to be, like 7, 8, 9B-ish. But I think that's probably a good, like, I want a fast model that's runnable on like laptop, like powerful laptops or like whatnot, right? But I think if you're on like phone, right? And so if you're trying to build an app for a phone, and all it is you feed it, you take in a bunch of like text information, like for example, stuff like autocomplete, like automatic like autocomplete when you're like typing on a phone and then you're like trying to complete it, right? Like that I think is where these like 1B models really shine. Because what you're able to do with these 1B models is you can get the base model and you can treat it as like a completion engine, right? And so it will complete your sentences for you based on your previous sentences, right? So you have like the prompting of just like, hey, here's the text message this person sent. Here's the text message this person sent. And so now this model will know how you do stuff. And purely on the inference side, you can have like better like text autocomplete. You can show like the top 3 tokens, well, I guess the current word you're typing in the top 2 tokens, right? And then you can basically just have better autocomplete. And that's kind of what this is doing, right? Like autocomplete has always kind of been transformer models. It's just they've not been purely decoder-based transformer models. They've been more FLAN P5 type models, right? And so now with these small models, what you're able to do is you're able to do a bunch of the stuff that was previously not, like still possible but not as good. And now you're able to use all the advances in large language models and build these small language models from those large language models. Now, of course, 1 billion parameters is still a pretty big model, right? Don't get me wrong. It's a pretty big model. But it's a lot better and a lot smaller than throwing a whole 8B model on a phone. Because not all phones can run 8B models. It is way better than putting a 405B model on a phone, because that's basically impossible, right? Like if you have like int 4, right? Like if you're doing like 4-bit quantization, the 405B turns to like a 202B model. So you still need 202B physical drive space on the phone. And let's assume you have a 1 terabyte phone somehow, right? Great. Now you have to inference on all of that, and so you need to store it into RAM, and no phone has 200 gigs of RAM. That is not a thing that exists yet. Maybe in the future, but not yet, right? And so these models exist purely for mobile, right? Maybe Raspberry Pi based stuff, but I think Raspberry Pi can run the 8B just fine, so I guess it doesn't have a GPU. So if you're doing CPU inference, then yeah, these would be better, right? And so now you're able to effectively have embeddable models. And so other people have done this before, but these models, in my opinion, are so far the best, right? They're better than Quen 2.5, right? And so you effectively have like really embeddable models that are like really good. Like this is like effectively the new standard for embeddable models, right? And so yeah, from there what you have is you have the really big news, which is the multimodal Llama 3.2. So this is Llama 3.2, 11B, and 90B. The 11B is just Llama 3.1 8B plus a 3B vision adapter. And the 90B is just Llama 3.1 70B plus a 20B vision adapter, right? So when I try these models out, purely via text, they perform exactly the same as 3.18b and 3.170b, because they are the exact same models, right? Maybe a little bit of fine tuning here and there, but they're the exact same models, like same text models. That's the base. They just threw on a vision adapter, and the vision adapter is really cool because now, I guess it's not really cool. People have done this before, right? Like this isn't anything like Chameleon, because Meta released Chameleon a while back, like a month or two, but like they released Chameleon, and what Chameleon was Chameleon was a model that was early fusion, right? You have text tokens, and then you have image tokens, and then you have text tokens again. And it was really cool because it was multimodal in, multimodal out, kind of like Gemini 4.0. And it's a model that, unfortunately, they released a little bit lobotomized. It doesn't do image out because obviously they don't want to get sued and whatnot. And so, in essence, some group made Anoli, which is just Chameleon but fine-tuned with image out, right? And Anoli's a pretty good model, right? Like, don't get me wrong, Anoli's good. But Meta doesn't. Meta just kind of has an allergy to releasing image out models. But these new llamas are very good because they're like the llama 3.2 is probably okay. I have to talk about molmo here because molmo is a model that was also released, but this time instead of just being open weights like a bunch of these other open source models are, this is truly open source. Like the dataset's open source, training code's open source, model weights are open source. Like it's entirely open source, right? And Molmo came a few days before Llama 3.2, and I would argue it's better, right? Like Molmo 7b, I'd argue is just as good, if not better, than Llama 3.2 11b in terms of vision tasks, right? In terms of in terms of text tasks, it is worse, right? Like don't get me wrong, it is not that much worse. It's a little bit worse, but like it's not as good. But for image tasks, it is like the best small model right now, right? Like I think it's better than Pixtral, it's better than 3.2 11b, it's better than that. And they also released a 70b, like Momo 70b, and in my opinion, this is better than Llama 3.2 90b, right? Like it's a very good image like model, like VLM. It's a very good VLM, and so it like the Momo series of models is kind of really cool because what they did is they effectively have a very high quality data set, right? Because they effectively generated a data set. And that, like, not generated, they took a caption data set and they effectively, like, optimized it so it's now a very high quality data set. And now it's an open source data set. And so you can use this to train your own models and so you can test it for architecture and whatnot on this very high quality data set. And so they trained a model on the very high quality data set. And because the data set was much higher quality than what Meta was using, because they trained on, like, what was it, 9 trillion tokens? That might have been for the 1 and 3B though. But they trained on a ton of tokens because Meta's strategy, what it looks like is they train on a metric ton of tokens. They train on so many tokens, right? And then what they do is they assume the model just gets intelligence, right? So they train, because what we've been seeing, like what Meta's been seeing and what they've released, right, is that when they were training Llama 3.8b, they trained on 15 trillion tokens, and that was kind of the point where the model stopped learning, right? So 15 trillion tokens for an 8B model. That's a lot of tokens, right? And if you have 15 trillion tokens, you can't have that much high quality data. I don't think that much high quality data even exists in the world. If you tune that down to like a 1 trillion token, a very high quality data set, what you then end up having is you have a data set that can train an 8B model, and if you train on multiple epochs, like if you train like 2 or 3 epochs on like 1 trillion tokens, the model can't memorize it all. So if you train on 1 trillion, if you train on 1 trillion tokens for like 2 or 3 epochs, instead of 15 trillion tokens for 1 epoch, I think the models will end up being very similar, even though you spent 1/5 the training compute, because the data set was that much higher quality. And so, in essence, what Momo's strategy is it's data set quality, right? You have much better data set quality, and this will lead to a better model in the end. And this is a very cool strategy, right? And so what you're seeing is that a lot of these companies are having very different ideas of where to improve the models, right? Because prior to like GPT 3.5's release, right? Like all the models were really similar, right? Because what happened is that all the research was open. So everybody was doing the best practices. But now the only people who have open research is like Meta and open source, right? And like all the open source stuff like Quad and DeepSeek and whatnot. Like all of Google's research, that's all closed, right? Obviously Google releases some, but there's the tweet about how if Google researchers don't like when their research is published, because that's implicit admission that their research isn't valuable, right? Because Google will only publish non-valuable research. And so now what you have is you have Google research, which is entirely private. And so Google is almost certainly using a different form of attention that isn't n squared probably in the Gemini models. And though maybe it's just ring attention and it's a little bit fancier. But like now Google's doing stuff there that we can't know about. It's probably just hardware buffs too. But like Google is probably has research going on that we can't know about. Then you have OpenAI. OpenAI closed their research off a while back. Like we don't know what's going on with OpenAI. Right? Like the fact that GPT-4 was a 1.8 trillion parameter model. It was like 220. It was an 8x 220b mixture of experts. Was like not like revealed like officially until like Nvidia announced the B100, and they talked about model sizes, and they had like 1.8 trillion parameter MOE on there, and it's like, okay, if we don't know the scale of these models or like any of that, like because they were using MOE before everybody else, right? Open source came up with MOE effectively independently, right? And so it's like, okay, OpenAI is going in one direction, and they're believing in inference compute now, and OpenAI is just kind of doing stuff. And it's like, we don't know what's going on there. Then you have Google also just doing stuff, and we don't know what's going on there. Then you have Anthropic also just doing stuff, and we don't know what's going on there. You have XAI doing stuff, and we don't know what's going on there. And so all of these research labs all have very different ideas on how the future should be, because they're all starting from the same point, right? Which was open research released up until like 2022, late 2022-ish, right? Like all that open research, they're building off of current open source, they're building off of their internal research, which is all pointing in a different direction. And so all of these companies have different ideas of how to get better models, right? So, like, let's go through the companies, right? The big companies. You have Google, they believe we get better models with higher context windows, right? They scale context window massively. And that's what Google's focusing on for their models. You have OpenAI, and they're believing in inference time compute. So instead of expanding the model itself, you expand how many times you let the model run, and so it stops being like fully auto-regressive in like real compute. And so that's a very different thing. You have Anthropic, who believes a lot in like scale, but also like post-training of the models. Like Anthropic does a lot with post-training, and also stuff like mechanistic interpretability and all of that, right? And so you have that, and then you have XAI, who believes, we can make the models better by giving it access to real-time data on Twitter, well, X now, but like you give the models access to real-time data. And so these are four very different techniques of how to improve models. And then you have Meta, who arguably is the closest to like scale purists here, where they're just like, let's just train it for longer. Oh, better model, let's just train it for longer, right? They're not doing anything fancy with Llama, they're just training it for longer. And so then you have open source, and open source, because open source tends to be under a lot of hardware restrictions, open source is kind of doing a lot of the algorithmic boosts, right? Because I would argue Mamba is a very open source like focused architecture, because you only have ever seen open source Mamba models, right? RxKV? I think it's RxKV. The other like recurrent neural net style model, those are also only being done in open source, right? Like Jamba is a combination of transformers and Mamba, and that's an open source model, right? Like open source, because of the hardware restrictions that open source tends to be in, because they can't just throw like, 25,000 GPUs at the problem, right? They have to come up with algorithmic improvements so that the models end up being better. And so I think like you just kind of have like 5 different paths for model improvements, and like none of them are clear which one is the best, right? Like you have a very unclear future of like which way to do models is the best, right? You have the Meta, like, let's just train for longer on bigger models, a lot of GPUs. You have that's producing very good models, and they open source it, so we can build off of that, right? You have a bunch of other open source people doing algorithmic improvements, right? So you have like Jamba, which is obviously Mamba plus Transformer. You have stuff like Codestral Mamba, where Mistral made a Mamba model, and you have like a bunch of like people in open source doing that type of stuff. You have more focused models in some areas of open source, because again, your hardware restrictions. So like Quen has coder and math models. You have Google being like, let's extend the context window. You have OpenAI being like, let's extend how expensive stuff is in inference. You have Anthropic being like, let's extend fine tuning so we can make smarter models. And it's like all of these companies have very different ideas on how to make models better. And I have the opinion that all of them will make the models better in different ways, right? Like again, Gemini is probably the biggest example of this, whereas like it can do stuff other models cannot, but it's not as good at doing stuff the other models can, right? Whereas you have OpenAI, whose technique is entirely just inference time compute. So they're going to have a slower model that might be smarter in the end because it's actually thinking about what it's doing beforehand. But they're also hiding a bunch of stuff. So I don't know how well that'll go exactly. You have, and then you have Meta with crazy scale. But what problem with crazy scale is you're going to have time between runs, right? Like you can't just be like, oh, let's make an architectural change here. No, you can't do that because your runs are going to take like 2-3 months. And so it's like, okay, if you know what you're trying to do, this is kind of the way you do it. But like, you're kind of stuck there. And so there's like pros and cons to like everything. And all the models will end up different over time. And I think since OpenAI released GPT 3.5 and there's been a closing of research at all of these big labs, what you've had is now you have just all of the labs effectively independently coming up with a whole bunch of ideas and all going in different directions. And so then when open source comes up with something and it's actually open, now all the labs have access, right? And so I think, again, this is my opinion again here, is that open source will continue to absolutely dominate in like actual use cases using of these models because open source is the bedrock for everything, right? Like open source models here, like I would not be surprised if GPT like 5 had some Mamba in it. I would not be surprised if GPT-5 also used inference time compute like O1. I would not be surprised if GPT-5 used like a bunch of the ring attention stuff that Google's trying to do. I would not be surprised if GPT-5 also did OLHF, did OLAIF like Claude. I would not be surprised if GPT-5 was trained on like 60 quadrillion tokens, right? Like, OpenAI, okay, so OpenAI, like I think all the closed like companies, they're all like building on top of open source with their own research, and open source just kind of have to build it on themselves. And so it's just like, cool. Now we have to figure out what we're going to do with this explosion of different ideas for models, right? Because if you go back to like 2021, 2020, when you had like GPT-3, right, and you had like Flan T5 and whatnot, you were kind of stuck with the models all acted very similarly. They're all really dumb. They all acted really similarly. And it's like, you don't have really much choice because, you use Flan, you use GPT-3, or I guess GPT-2, or like whatever. And it's like, cool. Amazing. The models are fine. But like nowadays, you have so many different models and you can pick so much. And so if you're an application developer, like an LLM application developer, this is a great time, right? Because you have so many models and it's like an amazing feeling to just like have all this stuff. And so I think I'll leave it there on that like hopeful note about this like explosion of models. I would like you guys, I will ask you kindly to like and subscribe to this video. I'm almost at 100 subscribers, and so it'd be great if you could subscribe. And I think I'm gonna leave it here. If you want to see another video from me, the last podcast episode will be linked here, and I will see you all in the next one. Goodbye.